All right. Number one. Fire one projectile. Use the dots below to do the following. Draw the trajectory, which is a fancy name for the path it travels through the air. B wants you to draw the x velocities. C wants you to draw the y velocities. So everything is made up of forward motion and vertical motion. What we're going to do is we're going to draw the parts of the motion that are those. And we're going to focus on those. All right. So first thing we need to do is we need to actually launch this sucker.
I'm going to guess it goes through all the points.
Oh, you would think.
Watch, it's not going to. It's supposed to be on.
Stop. Okay, so it follows through the dots. Shocker. You're exactly right, Cannon.
You're drawing a line through?
Yep. Draw a nice curved line through the points. Hopefully a better curve than I'm drawing. So, the trajectory is a parabola. And that should make sense because it's a combination of forward motion and vertical motion. Okay? So it's going up and down while it's going forward. So you put that together and it makes a parabola. Okay? So the motion is a parabola. So now we're going to draw the forward motion. So I'm going to do this again. But I just want to look at the forward green arrow. So there's a forward green arrow there. Whoa, ah. Okay, so there we got the first one going up. Watch its motion as it goes forward. We're looking at the forward motion. You'll notice that that green arrow doesn't change. So what we're going to do is we're going to go ahead and draw the forward motion to just be a straight arrow of the same size all the way through. Okay? Just a nice constant motion.
I'm going to throw a rocket. I think I'm ready.
Now we're going to look at the vertical motion. So we're going to look at the vertical arrow now. So there it is. It's pretty large. Now it's kind of medium size. Now it's small. Now it's 0. Now it's small but in the opposite direction. Medium in the opposite direction. Large in the opposite direction. So we're going to draw the vertical motion now. And the vertical motion is going to start large at the bottom. Medium next. Small next. 0 at the top. Small but down. Medium and down. And large and down. So, we drew the trajectory that it follows. It follows a parabola. And it does that because it's going forward while it goes up and down. We drew the forward arrow, which is the exact same every single time. And we drew the vertical arrows that get smaller on the way up and larger on the way down. All right, excellent. Flip her over to the back side of that page. You guys are on your own here. Going to do 2, 3, 4, and 5. So, I want to know for 2, what is happening to the x velocity as it goes up at the highest point and as it goes down. Is the x velocity speeding up, slowing down, constant, or at rest? Do the same thing for the y. What happens to the y velocity? On the way up, at the top, going down. Is it speeding up, slowing down, constant, or at rest? And then I want to know what affects the range. Range is how far across the ground it goes. Is it the x velocity or the y velocity that affects that? And then is it the x or the y velocity that affects the height? So I want you to do 2, 3, 4, and 5. The word component is one you're going to see pretty frequently. Component is just a fancy word that means part of. So the x component is the x part of the velocity. And the y component is the y part of the velocity. So use your picture on the front page to help you answer those. So what's happening as it goes up in the forward motion, in the y motion? What happens at the highest point? What happens on the way down in the forward motion and in the vertical motion? And then what happens to affect the height? What affects the range? Okay? Go ahead and take a minute and answer those. All right. There we go. Oh, and let's start with you in the back. What's happening to the x velocity on the way up? It is constant. So on the way up, the forward velocity is constant. And you can see those arrows don't change on the way up. Good. Caden, what about at the top? It is constant at the top. It's the exact same as it was. Okay, what do you think, Ken? It is constant. All right. So, here's what you should know. You should know that the x motion is constant. No matter what. No matter what. On the way up, forward is constant. On the way down, forward is constant. At the highest point, forward is constant. It's always constant no matter what. The forward motion is always going to be constant.
Very, very large gust of wind and it pushes it.
But we're ignoring air resistance, so
Why?
don't worry about it. The reason we're ignoring air resistance is because usually it's very small so that you can ignore it, and when it isn't small, it's a pain in the butt, so we're just going to assume it's not there.
Countdown in the bottom right corner must be.
I'm recording. It tells...
Oh, really? Can it
yeah.
hear me?
Yes.
Really?
Yeah.
Am I going to be
So-
on the YouTube video?
Yes. So, shh. Okay. All right. Yeah. So, what about the vertical motion? So, Luke's excited now. So, Luke, tell me about what's happening to the vertical y velocity as we go up. It is slowing down. So you can see that they get smaller on the way up. Cadence, what do you think is happening at the highest point? Good guess. It's almost constant. It's close to constant. It's at rest. Yeah, it's 0. You're close. And Lisa, what about on the way down? What's happening to it? It's speeding up. Oh my gosh, it's like free fall. So the last unit slowed down on the way up, stopped at the highest point, sped up on the way down. Same thing is happening here. So what I want you to see is that the forward motion is what we did in Unit 1, right? Constant velocity going forward. And the vertical motion is like we did last unit. It's free fall. So it's acted on only by gravity. And that is exactly what's going on. It's acted on only by gravity. There's nothing affecting it forward. There's nothing affecting it backwards. It's only gravity acting down.
So everything connects to the circle of life.
Something like that, yeah. Okay, Simba. All right. So, what affects how far forward it goes? Of the two components, x and y, what affects how far forward it goes? Luke. The x velocity affects how far forward it goes.
Can I tell you why?
Go ahead, Ken.
because it's like, think about it like domain and range
Yeah.
in math.
Oh,
It's
no.
left to right how far.
Yep. And X is the forward motion. All right. What about height? What's affecting height? Hayden. The Y velocity is affecting height.
I don't think this is gonna help me because I suck at domain and range.
It's not like that.
Good.
All right. So this is what we've got going so far. We've got motion going forward. That is constant. We've got motion up and down. Gosh. We got motion up and down that's free fall. We know that the forward motion affects how far forward we go. We know the vertical motion affects how high we go. And that's what we're starting off with. So you are going to need your computers. So go ahead and get them out. The first thing you're going to do is you're going to change the speed. So start at a low speed, maybe 3, 5, something like that. A low initial speed. Click the red icon that will launch it. And look at the motion. Then you're going to increase the speed. So let's increase it to, say, 10 or 8 or 9. Something consistent. Then launch it. Once you've done that, increase the speed again. And you're just increasing it a little bit at a time and then launching it. Once you do that, you want to analyze what's happening. The easiest way to do that... What do you want? Get out of here, Fox.
Get out, Fox.
That's me. I can say that.
Yeah, you missed it, bro.
I do like Fox's shirt today. It's nice.
Wait,
Okay.
is Fox in your class?
Yeah.
Where?
So, what you want to do then for number 6 is you want to describe how does increasing the speed affect the range, how far it goes. How does increasing the speed affect the height, how high it goes. How does increasing speed affect the time, how long it takes. Here's perhaps a helpful way to do that. So take this little blue box. It's got a little crosshair. Get back here, man.
I was throwing away the trash can.
If you put it at the end of the motion, it will tell you how long it took to get there and the range. Then you move it to the next one, how long it took to get there and the range. Go to the next one, how long it took to get there and the range. So you can use that to figure out how far it went each time. Okay? You can also use it to figure out the time. If you put it at the top point, and the top point is this little green dot, if you put it at the top point, it'll tell you the height, how high it went for that motion. Okay? And you can figure that out. So that's what you're doing for number 6. Once you get through number 6, you're now going to change the masses. Okay? So hit the eraser. That'll get rid of your launches. And now you're going to change the masses. Start at 1. Launch it. Change it to 2. Launch it. Change it to 3. Launch it. See what happens when you change the mass. Once you've changed the mass, you go to the last page. You're going to fire the cannon at several angles using the same initial speed. Start at something small. So the smallest angle you can do is 25. Okay? Launch it at 25. And then slowly increase the angle. I would go 5 degrees at a time. So go to 30 and then launch it. It wants you to do at least 10. At least 10. So start at 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay? Go ahead and do those and just change it, launch it. Change it, launch it. And just see what you end up getting. See what happens to the motion. Okay? Describe how the height changes. Describe how the range is affected. Which angle goes the highest. And which angle has the longest range.